I've actually added one more example to lesson 24, and that deals with when you're encountered with complex fractions when you're trying to compose functions. I believe there is one like this in ALEX, so I wanted to give you an example to kind of help you with that problem. So in this problem, we're given f of x is equal to 1 over x minus 2, and we're asked to compose this function with itself and then find its domain. So to get started, that would be f of x, which means I'm going to take f, and wherever there was an x, I'm going to put f of x. So this creates a complex fraction, and a complex fraction occurs when you have a fraction within a fraction. One strategy you can use to get rid of a complex fraction is to multiply by the common denominator of all your fractions on the top and the bottom. So the common denominator of this fraction, well, we only have one fraction within the fraction, and that denominator is x minus 2. But and I'm allowed to multiply by x minus 2 over x minus 2, because if you think about it, that is actually equal to 1. Because when you divide something by itself, it's equal to 1. And when you multiply something by 1, you don't change its value. So on the top, you would have 1 times x minus 2, which would just give you x minus 2. On the bottom, we're going to take this and multiply it by both of these. Well, when we multiply x minus 2 by this, we would have x minus 2 over x minus 2, or just 1, minus 2 times x minus 2. So just to notate that on the side, this is how I got 1. So that would be, these would cancel to 1 is one way you can think of it, or x minus 2 over x minus 2 would just be 1. And I purposely didn't multiply because I want to make sure that I distribute this correctly. So that's going to give me x minus 2 over 1 minus 2x plus 4, which is going to equal x minus 2 over negative 2x plus 5. All right, so now let's talk about domain. So remember, we need to look at the domain of the original function, which was 1 over x minus 2, and we do have a fraction. So remember, to find the domain of a fraction, you say the denominator can't be 0, so x can't be 2 if I add 2 to both sides. And then to look at the domain of the embedded function, then I say, which is this, then I say the denominator can't be 0 again, so that would be negative 2x plus 5 cannot equal 0. So negative 2x cannot equal negative 5, or x cannot equal 5 over 2. So if I eliminate both of these numbers from the set of real numbers, that's going to give me from negative infinity up to 2, union 2 to 5 halves, because 5 1/2 is 2 1/2, union 5 halves to infinity.